All right, so in this Edpuzzle, I'm just going to look at a couple things that are in Chapter 11 that you will see in Algebra 2, but that we didn't test on and didn't focus on necessarily. So I just want to go over them so that they've been in front of you before, and that so that when you see it in Algebra 2, you recognize it, but we're not going to spend a ton of time practicing that and things like that. So first, before we look at the actual problems, you guys know that if we have something like this, let's go plus 6 equals 5x plus 6. You guys know that if we had something like this, we would subtract 6 from both sides and those 6's would go away. Essentially, if we have a plus 6 over here and a plus 6 over here, they really cancel each other out. Right? Same idea if we had a different equation. That was like negative 7x minus 15 equals 8x minus 15. You guys know that this minus 15 and minus 15 would cancel out. Now, the same idea is true if you had something like this. And this will be super obvious, but you'll see what I'm getting at. Here, we could multiply both sides by 4. Multiply by 4, these would go away, and then we'd be able to solve for x. But essentially what you can do is just say, hey, both sides are being divided by 4. Let's just get rid of those, and we know that x3 equals x. Now, this idea right here is really what we're going to do with something that looks like this. Now, you're looking at this and you're thinking, wait a second, this is not even close to what we looked at. Well, hang with me for a second. Whenever we approached these problems, we said that we needed to get a common denominator, right? Now, over here, something that's a little bit different that we didn't see in our problems is that the stuff on this side of the equal sign can be factored. So we know that this would be x minus 7, x plus 7. And some of you might already see where I'm going with this. But if we have an x minus 7, and an x plus 7 over here, and then we look to this left side and we see that our common denominator is going to be x plus 7, x minus 7. Then once we get that common denominator, we actually are allowed to just get rid of all the denominators because they're all the same. So now we have 3x plus 7 plus 3x minus 7. And then we didn't have to change anything over here because it already had the denominator we needed. So it's just going to be equal to 9. So then we would distribute the 3's. We have a positive 21 and a negative 21. We have x equals 9 over 6, which would just be 3 over 2. So you can see that that's a lot easier than cross multiplying, that if you can get common denominators everywhere, then you are able to cancel out all the denominators, get rid of them all, because they don't change anything. And then you can just solve the top. Let's look at one more example. We see that our first goal would be to try to combine these, but we notice that our denominator can be factored. So we're going to factor that just to see what's going on. And we notice that our factor denominator on this side is both of these put together. So that clues us in to saying that we can get a common denominator all the way across and then cancel our denominator. So here we need a y plus 3. Here we need a y minus 2. Now that we have the same denominator all the way across our equation, we can get rid of them. Then we have 4y plus 12. Now, we've got to be careful because this is a negative 7. So we'd have negative 7y plus 14, and that equals 5y plus 2. Now we combine like terms. I'm going to bring this over here and that over there, so we would have 28 equals 8y. Oh, 24. And y then equals 3. So you guys can see how that's a lot easier than cross multiplying, that if we can get a common denominator all the way across, then we would be all set. Now, this wasn't really an option in the problems that we had. If you look at the ones that we crossed out from the puzzle time, this is what it was looking for you to do, but we were not going to spend time on this at this point. All of yours had something where it was like, maybe it was like this, over 2x plus 6x equals x plus 3 over 7. I mean, not this exactly, but something similar to this, to where getting a common denominator, these were like what you had. We're getting a common denominator here and here was pretty easy, but to try to get it to match this one, well, that would be pretty difficult. So that is why we didn't talk about it, because again, this is something that you're going to hit hard in Algebra 2. So I wanted you to get good at this now, at least see this idea of crossing out the denominator, and then you guys will rock it out when I have you in 2 years. So that's it. Good job. Thanks for watching. We'll see you next time.